Hello, welcome back. In this video, we are going to learn about logical addressing part 2. So let's look at the agenda. We will be introducing the audience to IPv6 addresses. Introduction to IPv6 addresses. IPv6 addresses, as we have learned earlier, consists of 128 number of bits. Earlier we have seen IPv4 addresses uses 32 bits. It is given in hexadecimal colon notation. So this is an example. Let's say this is a binary number and it is actually 128 bits. So the initial bits are 10101111 followed by zeros and then like this. So it can go up to all ones when you reach 128 bits. Now these binary numbers are then converted to hexadecimal numbers. So the original number, if you convert the binary number to hexadecimal number, it will be AF0C colon 0062 colon 0000 colon 0000 colon 0000 colon 9BFF colon 0000 colon FFFF. So how many blocks are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 blocks of hexadecimal digits are there. We can very well abbreviate it like AF0C colon. Since these two are 00, we can omit them and simply write 62 colon. All zeros can be written as 0, 0, 0, then 9BFF, then 0, then FFFF. And more abbreviated format can be AF0C colon 62. Now since there are 3 zeros over here, you can just write it like this with a gap. So there will be a gap here and followed by 9BFF colon 0 colon FFFF. So this is the hexadecimal notation. Now what is the address space? Address space will be 2 to the power 128. So this is the address space of IPv6 address as opposed to 2 to the power 32 address space for IPv4. Let us look at the various types of addresses used. Number 1 is unicasting. Number 2 is multicasting. Number 3 is anycasting. Number 4 is local address type. And number 5 is reserved address type. Let us understand these address types one by one. Unicast. Unicast means node-to-node connection. If there is a source node and there is a recipient node, then there will be a single point of connection between the source and the destination. So messages or packets will be sent from the source to the receiver. This type of address consists of several fields. We start with type identifier, consists of 3 bits and it defines the provider base address. Next is registry identifier. It consists of 5 bits and it defines the agency that has registered. Next we have provider identifier. It is variable and roughly consists of 16 bits. It defines the provider. For example, the Internet Service Provider or ISP. Next we have the subscriber identifier. It is 24 bits. It is basically the organization that has subscribed to the ISP. After that we have the subnet identifier consisting of 32 bit. Each organization can have a large number of subnets, let's say S1, S2, S3 and so on. So it is defined by the subnet identifier. Next we have the 48-bit node identifier which defines the node in the particular subnet like N1, N2 and so on. So this is unicast addressing. Next we have multicast addressing. In multicast addressing there is a single source and there is a group of recipients. So this group is understood by the group address. Basically, multicast addressing is defined by the group address, and the source can send it to the group address, and all the devices that are connected to the group address will get the message. Let's say D1, D2, D3, D4 and D5. So all these devices forming the group address will get the message from the source. So this is known as multicast addressing. Next, we have anycast addressing. In anycast addressing, there is a single source and there is a group of devices D1, D2 and D3, and the source can send the packet to any one of the devices in the group. So this is anycast addressing. Next, we turn our attention to local addressing. Local addressing can be of two types, and it is basically used when you want to send any messages in private network outside the internet. And there are two types of local addressing. One is called the link local address, when you have an isolated subnet, and you can also have site local address when you have an isolated site in several subnets. So the addressing structure is like this. For link local, the first 10 bits are like this. The next 70 bits are all zeros, and the 48 bits are reserved for the node address. So total 128 bits. For site local address, the first 10 bits are of this format. The next 38 bits are all zeros, and after that we have 32 bits which will define the subnet address, and then the next 48 bits will define the node address. Next, we turn our attention to reserved address type. The type prefix is all zeros, and we have 4 different types of addresses which are reserved type. One is the unspecified. This consists of all zeros, and this is mainly used when the device does not know its address and it sends a message to the internet to know its own address. Loopback address is used when the device wants to know whether it is active or not without getting connected to the internet. So this consists of 128 bits, and the bits are like this, all zeros, and the last bit is 1. Next, we have the compatible addressing. This is used for transferring IPv4 to IPv6. Mainly used when a node having IPv6 wants to connect to a node having IPv6, but it passes through an intermediate node which is using IPv4. So this is known as compatible. It consists of first 88 bits are all zeros, then next 32 bits will form the IPv4 address. The last one is the mapped address type. Here also it is used for transferring IPv4 to IPv6, but in this case the node having IPv6 wants to connect to node having IPv4. So this is called mapped, and the first 72 bits are all zeros, then 16 bits are all ones, and followed by IPv4 address 32 bits. To summarize, in this video we have learned about introduction to IPv6 addresses. We have understood that we require 128 bits for the addressing. We have understood what is the address space. It is 2 to the power 128. Then we have understood the hexadecimal notation of IPv6 addressing. After that, we have learned about different address types. We have learned about unicasting, multicasting, anycasting, and so on. So unicasting basically means one-to-one connection. Multicasting means one to actually to a group of networks, devices. Anycasting means one to any one of the group. Then we have understood local addressing, which is mainly the private addressing scheme. And we have understood the reserved address types. Thank you.